So what we try to do here is to write down the equations of motion in the interaction pictures. Well, the starting point will be we take the total derivative of an operator in the interaction pictures. By definition, the operator in interaction picture can be written as the summation of the transformation of a unitary operator with the operator in the Schrödinger pictures. And then we used the product rule the first term the second terms with the idea that this is a partial differentiation because we are only changing the t, and the last term like here. Well, since we have the u naught to be well defined, which we just use the exponentiation of the free field Hamiltonian, and we define that as the middle term as the differentiation of time of the interaction operator then we can carry out the total derivative of time for the first term and the last term using the factor, the properties of exponentiation the same term here. I see that there is be a minus I, so you take this minus I down with the h naught that now is placed at the last part. The h naught has to be placed here since h naught is an operator. Well, what is this term? This is just the operator in interaction picture. Similarly, this term. So therefore, summing up all the terms, I will just have minus I and then a commutator of OI and h naught plus the partial derivative of time for the operator in the interaction pictures. Well, taking this term back, completing the equation, then we arrive at the equation of motion in the interaction pictures for any kind of operators. But most likely, usually the corresponding operator we are studying is not explicitly in time. Therefore, this one is equal to 0 for most of the time. So therefore, this equation looks very similar to the Hamiltonian equation of motion, but we do not need to use the full Hamiltonian. We just used the free Hamiltonian. Is it in contrast in Heisenberg pictures? that we used the full Hamiltonian. So it turns out that will be an advantage of studying quantum field theory in the interaction pictures.